So here I am asked to solve this system of equations with three variables. I am actually going to use a combination of substitution and elimination because I want you to be able to use whatever feels most comfortable to you. If you like substitution in certain spots, use it. If elimination works better, then use that as well. I don't want you to feel stuck to have to use one or another. So in this case here, getting a variable alone, I'm going to start with substitution and I'm going to get a variable alone first. So I'm going to look through here and there's a couple that I could choose. I could choose y here and get that by itself. But what I'm actually going to do is I'm going to choose x because that's going to give me a super simple equation here when I add 2y to both sides. So that gives me x equals 2y. Now let me be clear, if you did solve for y and did those same steps but with that variable, it would still work. I'm just trying to make things simple and I can kind of foresee this is going to be helpful. So step one, done. We are just getting the variable alone. We got x equals 2y. So now I'm going to go ahead and move on to the next step, which is substitute for that variable. So I'm going to take this and I'm going to substitute it up here into my first equation. So what that means is wherever I see x, I'm going to plug in 2y. Then I just put the rest of the equation here and I'm going to start simplifying. So I'm actually going to keep this in the same color because I'm not changing equations just yet, but I'm going to distribute and simplify in this here. So 4 times 2y is 8y. And then I'm just bringing down the rest of the equation. I'm going to combine like terms to get 9y minus 2z equals negative 6. Now that I have this all simplified, I'm going to box it because this is going to be important later, and I'm going to come back to this equation. So I'm going to leave that there for now, and I'm going to go ahead and move on to the next step here. The next step is, well, it's repeating step 2 and 3, but for the other equation. So what that means is that I'm using substitution again, but I'm using it for equation 2, and I'm going to get something a little bit different. So anywhere that I see x, I'm going to plug in 2y, and then the rest of the equation, I'm going to read that out as well. Now I'm going to go ahead, again, I'm repeating steps 2 and 3, so I'm now distributing and simplifying. So 2 times 2y is 4y, minus 3y, plus 3z equals 9. Combining like terms to get y plus 3z equals 9. I have y plus 3z equals 9. Now I have two equations with two variables, y and z. And now I'm just going to use what I know about two variable systems to solve for y and z. So this is just like a two variable system now, just talking about the two equations that I've boxed. So I'll go ahead and do this one here in orange because now what I'm doing is I can use substitution or elimination or whatever is the most helpful. So what I'm actually going to do is I'm going to use substitution. So I'm going to subtract 3z from both sides here, which gives me y equals 9 minus 3z. Now that I have this, I'm going to use substitution and plug it into this equation here. So wherever I see y, I'm actually going to put 9 minus 3z. And then bring down the rest of the equation as well. Now I'm going to distribute and solve. So 9 times 9 is 81, minus 27z, minus 2z equals negative 6. Combining like terms here to get negative 29z. And I'm going to subtract 81 from both sides. Gives me 29z is equal to negative 87. So I know this doesn't look great, but the nice part about this is if we divide both sides by 29, again, I'm getting cramped for space here, so I'm going to squeeze over to the right. I'm going to be left with z is equal to negative 3. So I'm going to plug this 3 into this equation here to find what y is equal to. So what I get here is y equals 9 minus 3z, and I know that z is 3, so I'm going to plug in 3 here. And 3 times 3 is 9, so y equals 9 minus 9, which is 0. So now I have two of our three variables. I have y and z. And now I'm going to plug that in my final step here. So we just plugged that back into the equation. Now our final step here is we're going to plug both of them back in. Okay, this one we don't need to plug both in because we have x equals 2y over here. So I'm just going to plug in y. So what I get is x equals 2 times y, and 2 times y is just going to be 0. So what that means is that x, my variable here, is also equal to 0. So now I have all three of my variables. I'm finished. Now again, just like when we deal with solving systems, we use this kind of as a coordinate. So x, then y, then z. So what my answer will look like is 0, 0, and 3. And that gives me my final answer. Good work, people.